In this video, I want to look at topic 64, example 4, where we graph a combination of transformations. So the graph represents y equals f of x. This is the one that's already been graphed in blue. And using y equals f of x, how can you graph a combination of transformations? So what they're giving us is this original function and have the graph completed again or displayed again for parts A and B. And what we're going to do is we're going to look at this new function. So let's label this in, let's go with red. So we'd say y is equal to negative f of x plus 2. And we want to see what these transformations do to our graph and how we would show them visually. So the first thing we want to look at is what are the actual transformations going on? Well, this negative here is a reflection. And since it's a negative, we're making the entire function negative, that's a reflection over the x-axis, which is going to be important that we're obviously reflected over the correct axis. And then this plus 2 here, hopefully remember that that is a shift left 2 units. So all of my points are going to wind up moving to the left 2 units. Remember that when it's inside these brackets or the parentheses or an absolute value function, anything like that, the movement is actually backwards. So since it's plus 2, we're actually going to shift to the left. So I'm going to show the shift left first. The reason for that is think of this kind of like an order of operations. My term x, I would add the 2 first. So that's the first shift I want to show. And then I would be taking that negative. So then I'll do the reflection over the x-axis. So all I'm going to do is I'm going to take any point. So I'm going to pick this point here. Anywhere there's a change of direction, really. So I'm going to take this point here. I'm going to move it 2 places to the left. Same thing with this one. We're going to move these 2 places to the left. Oops. I'm supposed to be erasing that. So that will go over 2 places. This would move over 2 places here. And then I could really just pick, the other points to kind of show the other part of this. And we're going to take this point here would go over 2. So we'd have something like this. And that'll be good enough. So I'm just going to draw a dotted line here because this isn't my final product, right? That is only the shift left 2 units. And we can call that G if you want to label it, however you want to label it, you can do so. Then what we're going to do is we want to then graph the reflection over the x-axis. So that reflection will be there. Let me get rid of that. So the reflection, I'm going to take all of my points and I'm going to reflect them across the x-axis. So this point here is 2 places away from the x-axis. So I'm going to move it 2 places below the x-axis when I reflect it. So that point would go right here. Then at negative 4, we have negative 4, positive 4. So I'm going to make that negative 4, negative 4. Notice that my x values are staying the same. We're changing the y values because it's being reflected over the x-axis. So this negative 3, 3 point would stay at negative 3 for x value, but it would become negative 3, negative 3. And then my final point, I've got negative 2, 5. So we're going to make that negative 2, negative 5. And now that I've shown both of my transformations, I'm going to draw this as a solid line. Just try to make sure that you make it pretty accurate. We're drawing by hand, it's not going to be perfect, but this would be my final answer. So this would be y is equal to negative f of x plus 2. It shows a shift left 2 units, that would be the green, and then a reflection over the x-axis, which we showed in red. All right, let's take a look at part B. This time we're looking to graph y is equal to 1/2 f of x plus 3. So we need to determine what the 1/2 does and what the plus 3 does. That 1/2 is going to be a vertical compression, right? So it's between 0 and 1. And if we go back here, on the outside, the k value being between 0 and 1 tells me that there's going to be a compression. So this would be a vertical compression. And then this plus 3, be careful here, it's outside of those symbols, those bracketing symbols. So that is going to be a vertical, a shift. We'll say a shift 3 units. And we're adding that 3, so it's going to be a shift 3 units up. Now keep in mind that in part A, it did say plus 2, but because it was inside the brackets, it's opposite, so we went left. In part B, the plus 3 is outside of those grouping symbols, so that's going to be a shift 3 units up. We just stick straight forward with that. All right, so we need to decide which of these transformations we should show first. Again, think of this as order of operations. Well, if I'm looking at the x value or f of x, I would be multiplying by 1/2 and then adding 3. So the first translation I'm going to show, or transformation I'm going to show, is actually the vertical compression. So each of these points is going to be compressed by a factor of 1/2. So if I look at this point here, this -4, 2, the x value is going to stay the same because we're vertically compressing it, but the y value is going to be cut in half. So if it's -4, 2, that's going to become -4, 1. So let me erase that there, and let's put this in green. So we would have the point -4, 1. And I would continue that process. So this point here, which is -2, 4, the x value of -2 remains the same, but it's going to be cut in half vertically, so that's going to wind up going down from a 4 to a 2. The -1, 3 will stay at -1, but this time it's going to be cut in half for the y value of 3, which would be 1.5. And then we have this point here, 0, 5. So we're going to cut that 0, 5 in half, and it's going to be 0, 2.5. So that would give us a good idea what our graph would look like there. And again, I'm going to draw a dotted line because this isn't my final version, and it would look something like that. All right, next we're going to do our shift 3 units up. So I'm going to take each of my points, and I'm going to shift them up 3 units. So this piece, this point is going to go 1, 2, 3 units up. And I'll do that for each of the coordinate points. So that goes up 3. This one will go up. I'm having trouble counting here. Be careful with this. It's in the middle, so we want to go up 3. So it should still be in the middle there. So that'll be right here. And the same thing with that 2.5. If we go up 2.5, it should be at, go up 3, 2.5 should go up to 3.5. So my graph will look something like this. All right. It's not going to be drawn perfectly. Again, we're looking for a pretty accurate sketch, but a vertical compression by 1/2 should be pretty easy. You can cut anything in half fairly easily. And then we can label this. We could say that this is y is equal to 1/2 f of x plus 3. I'm going to get rid of that little extra writing there. And that's how you would show a combination of transformations if you were asked to graph them. Really, it comes down to just knowing what the transformations are based on the new function or the new equation, and just making sure you apply the transformations in the correct order. Think of it quite like PEMDAS, kind of an order of operations type problem.